algebra. We are going to be using the newest packet that I gave you the last time I saw you, which starts with Unit 11 stuff. We're going to take a break from Unit 10. We will eventually go back to it, so don't get rid of those packets. But we're going to start off with something that I thought would be a little bit easier to teach you remotely as opposed to Unit 10 stuff, which can be a little tricky. So, we're going to start talking about square roots, which we've already kind of done a little bit of this year. The first part we're going to talk about is perfect squares. And remember, perfect squares are numbers that when you square root them, you get a whole number. It's not a decimal. So perfect squares are like 25. Square root of 25 is 5. You don't need to do a factor tree with perfect squares. For this, you can ignore the negative for right now. The square root of 100 is 10. And then there's a negative out in front, so it's negative 10. This one, you're going to have 2/3 times the square root of 9 is 3, because 3 times 3 is 9, and then you multiply 2/3 times 3, giving you 2. You can always use your calculator if you're not sure what that equals. This, you can do square root of 100 is 10, divided by 5, so 10 over 5, you're going to get 2. This you can simplify each piece. Square root of 16 is 4, square root of 4 is 2, multiply them together, you get 8. So not too bad. This one's going to be 5 over 2, because square root of 25 is 5, square root of 4 is 2. So perfect squares make it nice and easy. When you don't have perfect squares, you're going to have to do those lovely factor trees. So if you recall factor trees, you're going to break it down to prime numbers. So something like 12 is 4 times 3, and then 4 breaks down to 2 times 2. You're going to circle the pairs and underline any leftovers. Pairs go on the outside of the radical. For each pair, you write the number down once. So a pair of 2's, write down 2 once, and then the leftover 3 goes under the radical. And again, you're only looking at the prime numbers, so we're not looking at the 4. All right, that's factor trees, and we did that not too long ago. So we'll do a few of these, and then we'll kind of move on to multiplying, which will be kind of new. So square root of 48, you can start off, you could do like 8 times 6. 8 breaks down to 4 times 2, 4 breaks down to 2 times 2, and 6 breaks down to 2 times 3. From here, you're going to circle any pairs. So I've got a pair of 2's, I've got another pair of 2's, and then underline my leftover 3. For each pair, you write the number down once. So I have a pair of 2's, I have another pair of 2's, so I'm writing it down twice, and then my leftover stays under the radical. Then you multiply the outside numbers together, you get 4 root 3. For 72, you could do something like 9 times 8. 9 breaks down to 3 times 3, 8 breaks down to 4 times 2, and 4 breaks down to 2 times 2. From there, you're going to circle your pairs and underline any leftovers. For each pair, you write the number down once on the outside, so I have a pair of 2's and a pair of 3's, and then my leftover 2 stays under. Multiply the outside numbers together, you get 6 root 2. When you get to number 3, it's a little bit different, because if you do the square root of 21, you're going to break it down, you have 7 and 3. There aren't any pairs. So if there aren't any pairs, you just leave it as the square root of 21. All right, and that's it. That's all you can do. So sometimes it can't be broken down any further. Sometimes that's the best you can do. All right, so those are factor trees. We'll do one more, I guess, and then we'll move on. So square root of 125, you could think of that as 25 times 5. And 25 breaks down to 5 times 5. All right, so you're going to circle your pairs, underline any leftovers. We have a pair of 5's and a leftover 5. Pair of 5's is going to go out in front with the 4. So we have the 4 out front, the 5's joining it, and then the leftover 5 stays under the radical. You end up with 20 root 5 for your answer. All right, we're going to skip 5 and 6. We're going to move on to multiplying radicals. When you are multiplying radicals, what's going to happen is you're going to multiply the outside number. I'm just going to put the hashtag that means number. Multiply the outside number by the outside number, and the inside number by the inside number. So you're going to multiply outside numbers together and inside numbers together. So when you have something like square root of 2 times square root of 3, those are both inside the radicals. You multiply those together. 2 times 3, you get 6. When it comes to something like this, outside numbers, 4 times 5 will be 20, and that stays outside. And then you multiply the numbers underneath. 2 times 5, you get 10. All right. The only thing you'll have to be aware of is after you multiply, you may have to simplify and do a factor tree. Not always, like 10 doesn't break down to any pairs. so it's already simplified, but you might have to simplify and do a factor tree for these once you multiply, because you're creating bigger numbers and then those can maybe be simplified. So I'll show you what I mean by these problems down here. So for number 1, you multiply the outside numbers together. 3 times 4 is 12. And then the inside numbers together. 5 times 2 is 10. And again, 10 doesn't break down. You could try and do a factor tree, but there's no pairs. So you're all set, and your answer is just 12 root 10. For this one, if you want to, you can think of this as a 1 in front of the radical 12. So when you multiply the outside numbers together, you're really doing 1/2 times 1, which is 1/2. And then underneath 6 times 12, you get 72. That's a pretty big number that we need to do a factor tree and simplify. All right, so I'm going to break down the 9 to 3 times 3, the 4 times 2. So I break down to a bunch of 2's and 3's. I'm going to circle my pairs, and then I have a leftover 2. The pairs go outside with the 1/2, so I'm going to have 1/2 times 3 times 2, and then I have a leftover 2 that stays under the radical. Half of 6, you'll get 3 root 2. All right, so you're just multiplying and then doing your factor tree stuff that we've already learned how to do. With this next one, 7 times 3, you get 21. 8 times 3, you're going to get 24. So you multiply outside numbers together, inside numbers together, and then you do your little factor tree. This is 6 times 4. This breaks down to 3 times 2. This breaks down to 2 times 2. So you got a pair of 2's, a leftover 2, and a leftover 3. The pair of 2's is going to go out front with the 21, and then the leftovers stay under the radical. Multiply 21 times 2, you get 42, and multiply 3 times 2, you get 6. So 42 root 6. Let's see. If you look at something like number 4, when you multiply the outside numbers together, there's technically a 1 here. So 5 times 1, you get 5. 20 times 5, you're going to get 100. Now, you could do a factor tree if you wanted to. However, 100 is a perfect square. The square root of 100 is 10. And there's still a 5 out in front. So we're really doing 5 times 10, which is 50. So look for those perfect squares so that you don't have to do factor trees. This next one, you get 1/3 times 1, which is 1/3. 9 times 9, you're going to get 81. Well, the square root of 81, that's 9. So don't bother doing a factor tree. And you got 1/3 times 9, which is 3. All right. Something else, remember, we also did was square root of 9 times square root of 9 is always going to equal 9. You might have forgotten that, so I multiply the 9's together. But any square root times itself will equal that number. Square root of 3 times square root of 3 is 3. Square root of 4 times square root of 4 is 4, etc. For this next one, you could multiply 2 times 1 and multiply 36 times 18. But 36 times 18 is going to be a really big number and going to be a really long factor tree. Here's the shortcut with this one. The square root of 36, that's a perfect square. Let's simplify this a little bit. So really we're saying 2 times 6, because square root of 36 is 6. 2 times 6 is 12. So we're really doing 12 times the square root of 18. And now we can just multiply the outside numbers together, be 12, and then we have square root of 18. And now we can do a factor tree with a much smaller number so that we don't have to deal with such a large factor tree. So you got a pair of 3's going out with the 12, and the leftover 2 stays under. So you get 36 root 2 for your answer. All right, the last topic that we're going to talk about is letters. Letters are a little bit different. What's going to happen is with letters, you're looking for the pairs. So we're still kind of looking for pairs. If you think about g squared, that's the same thing as g times g. All right, and if you were to circle the pairs, we'd have 1 pair of g's. 1 pair. That 1 is going to become your new exponent. So we're going to end up with g to the first, or just g. You don't have to put the 1, but I'm just letting you know it becomes your exponent. So let me show you with this one. If there weren't any pairs, by the way, then the leftovers would stay under the radical. So like g squared, f squared, you would end up with, g times g and f times f. G squared, f squared. There's a pair of g's and a pair of f's. All right, for each pair, you write it down once. So 1 pair will be my new exponent. 1 pair of f's, that'll be my new exponent. There's no leftovers, so I don't need a radical. When you look at, I'm going to skip this one for just a second. If you look at m to the 6, all right, this is the same thing as saying m times itself 6 times. If you circle the pairs, you're going to have 1, 2, 3 pairs. So 3 pairs will be, 3 will be your new exponent. So it'll be m to the third. All right, m to the eighth, you could write it down 8 times if you want to. 5, 6, 7, 8, and then circle the pairs. You're going to end up with 4 pairs of m's. So m to the fourth. All right, essentially what you're doing is you're dividing by 4. Or not dividing by 4, I apologize. Dividing by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. 2 divided by 2 is 1. That's essentially what you're doing, and then it'll make it a lot shorter instead of having to write down like 6m's or 8m's or 10m's. So like if you have m to the 10th, you could write out 10m's if you want, but you're going to end up with 5 pairs. So that would be g to the 5th. For this one, you're going to have 7 m's, and again, you don't have to multiply, you don't have to write it all out if you don't want to. But with this one, you're going to end up with 3 pairs and 1 leftover. 3 pairs would be m to the third, and the leftover stays under the radical. All right, so you're essentially dividing by 2, and then the leftover will go here. So 7 divided by 2 is 3 with 1 left over. K to the 9th, if you take 9 and divide it by 2, you're going to get 4 with 1 left over. All right, 4 times 2 is 8, plus 1 more is 9. So what will happen is it's going to be 4 for our new exponent, and then there's 1 left over. I'm leaving a little bit of space between the k here and the square root here because I still have to do g. I want to have all of my letters out front and anything under the radical all together over here. G to the 8th, we're going to end up just doing 8 divided by 2. You're going to get 4 pairs. G to the 4th, there's no leftovers, so there's nothing that needs to go under the radical for G. All right, and so this would be your answer. All right, if we go down here, K to the 13th, you can divide by 2. 13 divided by 2 is 6, and there'll be 1 left over because it's odd. 12 divided by 2, that's 6. That's even, so there won't be any leftovers. 17 divided by 2 is 8. That would be 16. And then there's 1 left over. So notice I left some space between these and the radical so that everything can go out in front together and any leftovers can go under the same radical. All right, for this one, we've got a number, square root of 16. That's a perfect square. Don't need to do a factor tree. It's 4. M to the 12th, just take 12 divided by 2. You're going to get 6. No leftovers. 11 divided by 2 is going to be 5, and there will be 1 left over. And then 8 divided by 2, that's going to be 4, and there's no leftovers because it's even. All right, and so there's your answer. This one, 8 is not a perfect square. You're going to have to do a factor tree. And you end up with a pair of 2's and a leftover 2. So pair of 2's here, leftover 2 underneath. And then let's deal with the variables. M, we've got 2 divided by 2, that's 1. You can put a 1 or not, it's optional. 3 divided by 2 is going to be 1 with 1 left over. And then 17 divided by 2 is going to be 8, that gives you 16, plus 1 more gives you 17. All right, and so then we have everything kind of all together out front and everything all together under the radical. All right, so that's it for day 1 of radicals. Thanks for listening.